This is a Compton scattering setup where we have the incoming momentum of a photon. It comes in, it hits a piece of metal, then another photon comes out with 1.2 kilo electron volts of energy, and then of course we also have an electron. And we're going to try and find out the de Broglie wavelength of the electron. So again, just like a photoelectric effect, it's all about energies. So we've got to find the energies and use conservation of energy. So I have momentum of my first photon. So I'm going to use that to find out the first energy. So the energy of my first photon would just be its momentum times c. So I can use that to find out that it comes in with 2.138 times 10 to the negative 16 joules of energy. And that's my total energy. Now, this is the energy of my second photon. I just need to turn that into joules. Now, if I turn that into joules, that'll be my E2. This photon has 1.920 times 10 to the negative 16 joules of energy. So obviously, it's less energy than what I started with. And that's, of course, because the electron has taken away some of that energy as kinetic energy. So I can find out the kinetic energy of the electron by subtracting the two energies so I can find its speed. So the kinetic energy would just be E1 minus E2. And that tells me that my electron has 2.18 times 10 to the negative 17 joules of kinetic energy, which I can then use to find out its speed. So just using a basic 1/2 mv squared kinetic energy formula, my electron would be traveling at a speed of approximately 6.92 times 10 to the 6 meters per second. Now that I have the speed of the electron, I can use that to find the de Broglie wavelength, or the wavelength of the electron in terms of its wave nature. Now, of course, the de Broglie wavelength is equal to Planck's constant divided by mv. Well, Planck's constant, of course, is a constant. I know the mass of the electron, and I did find the speed of the electron, so I can put those into the expression and calculate its wavelength. And if I do that, I get 0.105 nanometers as its wavelength, which of course is really small as expected.